Okay, our next speaker has the rare honor of being the only person speaking today that has a poster of a quote of them in the toilet. Apparently it was shared on his family Facebook, and they're all over it. So it's worked out. I don't think we chose you to go in the toilet specifically. If we did, it was Richard's fault, which is probably why he just left the room. Let's get a huge round of applause for Ian Chilton.
Good afternoon. I'm Ian Chilton from LONAP. I'm an engineer, not a public speaker, so this is very much outside my comfort zone, but hopefully you'll find it interesting. It's very much how we use network automation in the real world kind of talk. So I'm going to introduce what is LONAP, what do I do, how we use network automation at LONAP, and then just talk about some new tooling I'm developing. Just a segue, recently the NetBox Labs guys have started doing a new podcast. So this was a couple of weeks back, so you might want to check that out and also check out other episodes. We talk there about my background, my journey into this kind of thing, a similar introduction to LONAP, how we use NetBox, all of those kind of things, so go check that out. So LONAP is a neutral, not-for-profit internet exchange point. In the UK, obviously we're in London. Established in 1997, all members are equal stakeholders. We have 8 points of presence across 7 of the major London data centres. We have around 250 members, around 350 connected ports. We peak at 1 terabit per second of traffic, which is about 130 million packets per second. We do all that with 4 full-time staff, so there's an MD, 3 of us that are technical. The other 2 technical guys are more traditional network engineers, coming from that kind of background. I come from a development and an operations background. We have a part-time bookkeeper, and then a board of elected non-exec directors. So obviously, automation is very important because we don't have huge teams of people. We do all this with just a couple of people, so the faster we can do things, the more reliable we can do things, the better. Connected networks, and there's a mix of internet service providers, content hosting networks, CDNs, some of the big names you'll recognize. Like I say, we have 8 points of presence across 7 sites. Those are the sites. We have 3 spines, and all the sites connect back to 2 of those spines. That's some of our racks. It's not going to win any cabling design awards, but it's very difficult to make all of these things look tidy, but we do our best while trying to do it practically. Obviously, the more Velcro and stuff you put on, the tidier you can make it look, but then we're constantly adding cables, taking them away, so that then restricts you, so we try to keep it sensibly tidy. The network diagram is unfortunately split across 2 slides because it's portrait and we don't have a landscape one. It's already out of date because I was in the data center yesterday afternoon and evening changing core links around, so it's already out of date, but never mind. We use Arista 7280 boxes on the edge, either QRs or SRs or CR3s, depending on what ports we need in that particular site. Some people connect to us at 100 gigs, some people connect to us at 10 gigs, some people connect to us at a gig. So we have a variety of boxes to provide those edge ports. They all connect back to 2 spines. That's the kind of other half of the diagram. Then we also run, obviously, other infrastructure to support that network. So we run a management network that both has a load of VLANs for our servers that run all of our other services and monitoring and all that kind of stuff. Obviously, we run terminal servers to get to the serial ports on these switches. Then we have a management VLAN that connects to all the management interfaces on the switches. So my job title is DevOps engineer, but as with any small company, I do lots of other things that's not really covered by that job title. Ranging from operations, development, software engineering, network engineering, sysadmin, many other things. That was one of the reasons I was hired, was to work on network automation, but There's lots of other things to deal with as well. So historically, until a couple of years ago, the network was entirely configured manually. There was one script that we used for provisioning the inter-switch links, because there's kind of several steps needed to do that. There's obviously BGP sessions and port configuration, all that kind of thing. But other than that, all of, if you joined LONAP, we'd plug the cable in, we'd manually configure that interface. We had templates, so when we got a new box, we'd paste the template in, and then we'd just manually configure ports. Obviously, that's not ideal, because then over time you get inconsistencies. When you're stood in the middle of the data center and you're trying to change things around, you don't really want to be typing stuff into switches that you then might make a mistake. So this is kind of what we ended up with. We use SaltStack for the network automation. We take data from a number of sources. IXP Manager is our big thing for all IXP data, so it's like our member database. It has the ports, it has contacts for members, it feeds into graphing, it generates root server configuration. So that really does a lot on the IXP side. Then we use NetBox for all our inventory management. So obviously we have all the switches, we have other hardware like terminal servers, but then we have hundreds and hundreds and hundreds of optics, because obviously our purpose is interconnection. So we manage all that with NetBox. And then we run a GitLab instance which has all of our code repos. And then configuration we put into GitLab a lot as well. Obviously, anything we push to a Git repo, you've got a history, so you can go back and see exactly what was changed when. You've then got backups. You've got visibility because it pushes to Slack. So when I push something to GitLab, it goes into a channel, and anyone in the company can go and see what the changes have been made, so you can kind of keep up with what others are doing. And then we have templates, configuration templates in there as well that are in Ginger 2. The SaltStack, we read secrets from HashiCorp Vault. The SaltStack then uses a Python library called Napalm that then actually talks to the devices. And then I've kind of put some other logos up there of the kind of monitoring stuff we use around that as well. We use Oxidized for network backups. So they probe the switches, pull out the config, and then that pushes to Slack as well. So whenever anything's changed and we have a Slack channel, it gives a diff of exactly what configuration's changed. So just a kind of interjection at this point. Obviously what I did is I took an existing network. It's obviously the internet is it's a 24/7, 365-day a year network. We can't, obviously we have to do maintenances occasionally, but there's no time when it's not in use, when it's not doing traffic. So we can't kind of take it down to apply these things, but also we can't break it. And so obviously that kind of brings a bit of pressure as well. Obviously if you have an existing network, then you're doing a lot of work to kind of come out with nothing, because ideally you're generating the same config that's actually there. But that means you've got a reference point. But then actually in reality, especially if this network has been in use for years, then you've got lots of inconsistencies that have crept in there that you don't know about. And it's also a good time to review the configuration. Should we be doing this differently? So actually, there is a load of changes to make, and it was a bit of a slow process to kind of apply all those changes, get everything, so it matched the templates, but do it in a way that we're not going to break anything. Obviously, the alternative is you have a new network, Greenfield. You can then deploy that without breaking anything, but at the same time as working on the automation, you're effectively producing the config and working on it. I was involved last year with the EMF camp, where in a couple of days we deployed 50 switches around a field. And that was similar to this. Like the hardware was all brought into site. We didn't have it in advance. We couldn't test all the configuration. We were doing that on site, but there was an event happening in a few days. We had, like I say, over 50 switches to deploy in a couple of days. And we started putting config on these boxes. Someone would take them out and put them in parts of the field, and then we'd find, we can't access that box because there's this little line of config that isn't in place. So it kind of works both ways. Okay, so the network like I say, the automation we started using SaltStack, but actually the way it ended up, all of the logic ended up being in the templates rather than using features of SaltStack itself. We also use SaltStack for configuring servers, and obviously with those, there's lots of things you're asking it to do. You know, create this file, create this directory, run this script, you know, all kinds of things, and SaltStack goes and install packages. It goes and does all that. In this case, I ended up with almost this one line. Go past that template, and this became beneficial later on, as I'll talk about. So just a couple of SaltStack concepts. So there's grains, which are basically facts from the device, or facts about the device. Some of these are fetched from the device itself. Some of them, we kind of have code that generates them based on other things. So, for instance, if a device has a management IP, we can work out, we have this kind of concept of a device. Each device has a unique number, which is the last octet of the IP, and that's used in things like the ASN and other various things. Whenever there's links to other switches, part of the IP becomes that device number, so everything refers back to that device number. So that all comes in the form of these grains. And then there's also a pillar, which is configuration we're going to supply into this thing. So like I say, we have this in a Git repo. Some of this is more static stuff, like, you know, these are the IPs of the NTP servers, of the syslog servers. Where do we send sflow to? Some of it is more dynamic. You know, we might have links. We might want to, like I was doing yesterday, we might want to replace or change some interswitch links on the network. So we want to depref them to get the traffic away from them, so it'll take another route. I would commit that to that same repo, which would present to the code in these pillars. But again, because it's in that Git repo, we have a history of kind of when that link was in service, when it wasn't. The good thing about the pillar is you can have lots of different YAML files, and they're all merged together. So I kind of came up with this structure where we have more global stuff and then more specific stuff, and these are all applied in order. And we don't do this, but a daft example: if you take an array of usernames, you know, you might add more users at different levels, and then you come out with this list of users. Some are only specific to a certain device, some are specific to a certain site. So that's really useful. And then there's this other concept called salt mine, where, again, we use this where we're provisioning interswitch links, because you need to know what's at the other side of that link. So you need to have details about the device. For instance, this switch I'm trying to connect to, what's its ASN number? So the way salt mine works is each device can push data into the mine, and then the device you're actually provisioning can draw data out of the mine. So again, you know, we have the device number in there, the ASN, the loopback IP, that kind of thing. So then, obviously, we have a number of templates. This is just standard network config, but then with templated parts in. So, you know, just some daft examples. You know, we might set up sflow on the box, or we might set up login hosts. That data is stored in the pillar in the configuration. But then when the template's rendered, it pulls in that data. We also can read secrets from Vault, so we can put like our SNMP community or license keys or anything like that in Vault. They don't then need to be put in the repo with the templates, you know, containing sensitive data. And then just a note, obviously we've got two ways we can apply config to a switch. We can merge or replace. If we use merge, we can do little parts of the config, so we don't have to apply the entire switch configuration. We can just say, oh, we're only interested in changing the login hosts or the NTP servers, so we only need to do that little bit. We might use merging to apply a whole switch config, but it only touches the parts that you're actually setting. What you don't know is that someone else hasn't gone onto the device and added config that you know, that isn't in your templates. An interesting kind of trick that you can do is, I've given two examples here. So you can like know something. So If we just had that bottom part and we set NTP servers that would be added in addition to the ones that are already there. If we do no NTP before it, it removes the existing config and then adds the new ones. Or we can default an interface, then we can set its config. Now, that's not like typing that into the switch CLI where it would remove the config from the interface and then set the new config so there will be an interruption to service. When we apply this as a config session that I'll show you in a minute, the switch will basically diff it all and come out and say, okay, we're just going to change these lines. Which, this might not come over in small text very easily, but that's kind of what I'm showing here. So the automation effectively does this on the switch. It goes on and it creates a config session. It makes a change. And then you go to the switch and say, okay, what's the difference between the config we just gave you and the config that's already running? And then when we commit that, we can either abort it, so we throw it away, or when we commit it, it will only make those changes. It won't start applying the whole config. And then what we kind of designed decision from the beginning was we weren't going to have this automation running by itself. So like I said earlier, obviously, like we don't want to break the internet. We prefer reliability over convenience. So we kind of made the decision that yes, we'd have all of this automation, but we would manually run it when we need it. So what I did is I basically wrote a little wrapper to Salt just to make it easy to run, particularly when other people were running this thing. So I kind of wrote this wrapper script called Run Salt. What that does is it applies the config in test mode, so we get a diff and we can see exactly what it's going to change. And then it says, do you want to commit it, yes or no? If we press yes, then it will go and make those changes, or we can abort them. Obviously, if data's changed or it's not doing exactly what we think it's going to do, we can abort that, go investigate, then come back and run it later. Generally, it's worked very well, and we can run it with a lot of confidence now that it's going to come out with the right thing. The other thing we did do is we get a daily email if someone goes if someone goes into our XP manager and changes some ports around because a member wants a new port, or some old ports have been taken away or anything like that, and then they don't go and run the automation, then you've kind of got outstanding changes. Those changes might sit around days, and then I might be in the data center and I go and run the automation against the device, and all of a sudden there's all these other changes that I didn't make, and the kind of it's stuff that someone else has changed days ago, data that's changed. So I'd rather know about those up front and be able to kind of apply them. So we get this daily email saying, hey, something's changed and you forgot to apply it. So that would be the end of the talk, except, just going back to the diagram earlier, if you remember the part where I said I wasn't really using much of Salt, because, all of the logic is in the templates. So then I kind of start, obviously Salt is kind of a big open source project. If that breaks, then our automation is broken, and unless we go digging around the code ourselves, we're relying on somebody else fixing it. So then I started thinking, well, what happens if we didn't use Salt? How hard can it be? Like, we're taking some data, we're taking some config, we're taking some templates, we render those templates, and we can still use napalm and push it to the device. So yeah, just to kind of, some more information about that thinking. So SaltStack worked great for us. It continues to work great. That's what we're still using in production. But obviously, if it breaks, then we're trying to operate a network, we're trying to make changes, it becomes a pain in the backside. Also, when there's, say, a new version of Debian, we're then kind of waiting for them. This just happened, there's a new version of Debian out. We can't upgrade Debian in production because we're waiting on SaltStack packages. They might do them quick, they might take months to do them. We're only using a small part of SaltStack. The other thing to get SaltStack to work is we've got a virtual machine that has a proxy process for every device. So obviously you've got to then manage those proxy processes. The other thing we found is if you have an error in your templates or data causes errors, then you don't necessarily get a straightforward stack trace. You might get a big, horrible stack trace, and it's like, well, where exactly is the problem? So often you have an inkling, like, I've changed this thing, so I'll go look there, but it's not the easiest thing to debug. So then I started thinking, if we wrote our own custom tooling, then the code's all within our control. We can run it from anywhere. If you had a tunnel to the management LAN to be able to access switches, you could run it from your laptop, or we can just run it from a simple server. We don't need this kind of infrastructure. It has minimal dependencies, though obviously it does require access to all of the data sources to be able to render those templates. It's faster. A salt run is about 30 seconds, which it's quicker than kind of working out the config yourself and logging into the switch and applying it, but it's kind of slow in the fact of when you run it, you kind of sat there waiting. 30 seconds feels like a long time when you're doing that kind of thing, or you stood in the data center, 30 seconds, it just feels ages. It's obviously more flexible, so we can start to build more things around it. So for instance, like I say, we want to depref a link. So rather than kind of changing the config and committing that, we can actually have the tool do that for us. So just go depref that link, and it will work out which switch that link is on and what it needs to do, and go actually do the thing. I lost my place. Oh, more flexible. And again, we can design the interface exactly how we want it to look, how we want it to work. And like I just explained, we can expand the scope of that tooling to do other things. So, starting afresh-ish. So this is literally hot off the press. So this thinking was about a month ago. Obviously, I do this and lots of other things, as I showed you the list earlier. So I've done kind of a month of development on this, except it isn't a month because I've been doing other things as well. The templates basically are the same, just with some of the saltisms, the grains, the pillars, that kind of thing removed. The config is basically what went into pillar before. And then there's this new project that are called LONAPs. Because I'm not very good at naming things. But literally, in the next 2 minutes, you'll know more about this than my colleagues. So it's a functioning tool. It can apply config, and it's coming together. I've kind of been using it to make changes, but no one else has seen it or used it yet. So you'll know more than them soon. There is kind of some safety concerns or kind of things I was conscious of. Obviously, breaking the tool in could be a nightmare. If you're in the middle of maintenance or you're stood in the data center and you run the automation and it errors, then you're a bit stuck, and then you've either got to fix it quickly or you've got to start managing that config manually and sort it out later. But the primary concern is to generate the correct config. We must not break the network. What we can't do is run it and it can't get, say, member data, so then it removes all of those interfaces. That would be a complete nightmare, and we don't want to go there. So potentially, or what I'm proposing, is it's better to fail than to generate the wrong config and break the network. We need to think about race conditions when committing the changes. So if say, I run the automation, and it says, oh, yes, this is the changes I'm going to make, but then in that time period, someone goes and changes the data, and then I say, yes, commit it, and it goes and renders the templates again, then potentially it commits a config that's different to the config that I said, yes, go commit that. So, what we want to do is render that config, store it, and at the point we commit it, we make sure we're going to commit the exact config that I approved, even if it might not be the very latest config anymore. The other thing we want to do is reduce the dependencies. So, if one of these systems is down, if NetBox is down, if IXP Manager is down, we don't want the automation to be broke. What if the network is down and we can't access those things, but we need this tool to fix the network? So the way I've gone about this is, rather than the tool making an API call and pulling the data at the time it's running, the data is regularly downloaded, stored in YAML files on disk, and then the tool just references those YAML files. Obviously, when we run the tool, we can go and update them, but if the source of the data is down or we can't access it, then we can run on that cache data. Obviously, we want to keep good logs and history. If something goes wrong, we want to better go back and work out why. One of the ideas I had for this was every time we run the automation, store the current running config of the device, the config we've generated, and any kind of parameters used to run the tool in a Git repo. And if every time we run it, we make a Git commit, then we have a really nice history. We can go back to any point in time and kind of start diffing configs and work it out. And the other thing is just to say, beware of vendor bugs. Obviously, any software can have bugs in. And we had, after we'd rolled out the automation, we had one thing where we were moving from port security to a static Mac ACL. Obviously, now we've got the automation, we can generate the config dynamically and pull in that kind of data. So we wanted a static list of MAC addresses that can talk on that port. Prior to that, we were using port security, which uses MAC ACLs behind the scenes, but it's dynamic. So the first MAC address that appears on the port, it creates an ACL and uses that. So when we were doing this, I tested the config. It all worked fine in the lab on spare boxes. And then I came to roll this out in production, ran the automation, load of ports go down. I'm like, oh, that's bad. So scrambled around, fixed them. It turned out a process had crashed on the switch. So we went to the vendor and help. They couldn't reproduce the problem. The config, as I thought when I did it, the config I applied was perfectly valid. Anyway, it took them ages to work out the problem, and it turned out to be that if they applied this config in the same config session, so if you apply the config and you take away port security and then you put in a Mac ACL, it's fine. If you apply that in the same config session, it hit a software bug, caused a process on the switch to crash, game over. So by using automation, we can somehow trigger bugs that we don't trigger by typing things into the switch. So obviously, be careful of that. It's not always a safe thing. So this is the tool. Quite simply, we can run it with a target, an action, some parameters, and it will go do something. So the targeting is obviously quite a foundational element. We want to be able to run this thing against a single device, against multiple devices. We might want to put a wildcard in, so we run it across lots of devices. We've got an action here of targets, which just shows me the targets it would run on. Getting a time check, 10 minutes, okay. We can run it on only edge boxes. We can exclude some boxes, or again, we can exclude it with a wildcard. If you run it across more than one device, then it will use threads and run them all at the same time. So, we don't have to wait for it to do all of these things. It will do them all, and then it'll come back. We can pull facts from the device. And then this is something we wouldn't normally do, but it's kind of good to illustrate the kind of interface. So if we want to set here's some manual configuration, go make this on these devices, then this is the kind of output we get. So it failed to connect to that one box. Two of the boxes already had that config. It's already correct, so we don't need to make any changes. We've got one box where it needs changes, so yes, let's commit that. Let's go make that change. So that's that's interface. The other little thing I did in there is I mentioned earlier we use Oxidize for backups. They then, that pushes to GitLab, and it also gives us Slack messages with the diff in. So what I did on this tool is I kind of made a little API call to Oxidize, so the minute you make the change, rather than waiting for Oxidize to get to 10 minutes and take a backup and show us that stuff, it kind of goes and pokes Oxidize and says, go check that device. So you run the tool, you can quickly flick to Slack and check it has actually made the changes you think. We can then we can print the config we're generating. That was something that kind of didn't work very well on SaltStack. If you were having a problem with it and you kind of wanted to just show me the config you're generating, it wasn't major easy to do, or it didn't work under some circumstances. So that was kind of one thing I really want to do, is to make it easily debuggable. Yeah. And then this is, the point I was trying to make there is we can load a specific template. So that template might just be a little snippet of template, like do sflow, or it could be the whole switch config, which then starts including lots of different templates. And then the other thing that I want to make easy with this tool is when we do maintenance, if we have to affect member parts, then we give them a load of notice, and this is the time we're going to do it. But then we also do it nicely by something some of my colleagues and peers came up with years ago, is this concept of BGP session culling. So what we can do is, if we want to do maintenance on an interface, rather than just pull it out and then a load of traffic is dropped while BGP reconverges, what we do is we apply an ACL to the ports that lets all traffic through except BGP. That kills the BGP session, all the traffic nicely drains away, and then we go and reboot the box or unplug the port or whatever, and all that traffic is nicely rerouting elsewhere. So someone's not in the middle of a Netflix film and all of a sudden it stops, because suddenly that interface isn't there anymore. And that's just an example of we can print that configuration, or we can actually apply it. The other thing I wanted to do with this tool is make it easier to develop or troubleshoot. So we can print the data out, we can download the config from the device. We can, like I say, we can print the config we're generating, diff the two. And then coming soon, I want it to do lots of other things. So really, ideally, we won't log into switches anymore. Anything we do, we should be able to run the tool. So if we want to depref an ISL, like I mentioned earlier, let's just run the tool to do it. If we want to look stuff up, like, Google emails us and say, there's a problem with the port or whatever, and we want to view light levels or something, like, you just go to the tool and it'll show us. Or like optic inventories, like we want to plug something in and we need a certain optic. Where is that optic in the network? We can do all that with the tool. Questions?
Awesome. Thanks, Ian. We have now made up our time from the bag throwing roulette exercise, so that's good news. Any questions? Right. One over here, Rich.
Hi. I've solved most of the same problems you've just described with Salt by using Salt Nornia, because the major problem I found was that the proxy minions take enormous resources and are really slow.
Yeah.
Whereas Salt Nornia responds like you described in seconds, sub-seconds. So it might be worth checking that out. If you wanted to still use Salt Nornia is the way.
Like I say, part of the rationale was we're not really using much of Salt. We're doing one thing. We're taking data and templates and rendering them. Like, do we really need Salt? But yeah, thanks.
I think there was one more. Yeah, just over there on the right.
Hey, Ian. Great talk. Thanks for that.
Thank you.
A quick question about your tool. It looks like it's generating CLI output, but then I saw a reference to Arista's API. How are you delivering it?
Basically, we're using Napalm as an intermediary. That kind of, if we did want to use other vendors, would give us some, standard interface for applying that. We could support other vendors. But yeah, basically, it's Arista config that you then poke in through Arista's eAPI, and then, like I say, you can give it that config, and then you can say, show me the diff between the running config and that. So it's kind of all the same thing. The config on the device is kind of the same as what you put in through the CLI, but if you feed it in through the API, it'll show you the difference, and then you can commit it. Does that kind of answer the question?
I think
if not, we can talk in the break.
One more here, and I think then we'll have to move along.
Really great system that you developed. How do you document all of this for the rest of the team to understand how this is all put together?
I'm probably better at writing code than documenting, because that's less fun, right? But yeah, with the obviously there's a little bit of documentation for this where I've written it as I was going along. I need to document it better. The original automation, basically there was a document. It was it's the readme.md in the GitLab repo. that was really long, that kind of covered all the different scenarios. If we want to do this, then do that. Here's how we run it. Here's the different ways we can run it. Here's how we do this thing, that thing. So, almost like writing a bit of a manual for it. Like I say, we're not a big team. There's 2 other people that would run this, not lots of people. Those people are network engineers, so they understand this config that's coming out. So we need documentation, but...
Yeah. So when you go on field trips, do you take the same transport, or does your manager split you up? Because that's quite a risk.
Well, ideally we're not all on the plane at the time. Not in case we die, but what happens if it breaks? Like I say, there's 3 of us, and it's a 24/7, 365-day network, so we do have to be conscious. I don't very often go very far from my laptop. If I'm going to the shops, my laptop is in the boot, just in case. Thankfully, I don't need it very often, but the time you don't have it is when you will need it. It always breaks during the night or when you're on holiday, of course.
All right, let's get another round of applause for Ian.